Welcome to the third part of my definitive laser series. In this part, we're going to be going over two things. First is, or mainly, we're going to be talking about the reflection. So adding a actor that reflects lasers that bounce off of it, as you would expect, a mirror. And the second thing we're going to do, which we're going to do first because it's going to be very quick, is making it so that when a laser hits a cube or hits a reflection or hits a bouncing actor, it will also keep the color of the laser that hit it. Because currently right now, if we play the project here, we have just purple lasers for the cubes and blue for the spawn, but we want it to be, if it hits blue, it should continue blue. So that's what we're going to be making today. So let's start with the color. So the first thing, or how we're going to do this, is we're simply going to go into our emitter here, and we have a current color. And what we need to do is our current color is used to activate laser and set right here. Now, to use that, we just need to now update it. So to update current color, what we'll do is on AC handler right here, not AC handler, in our activate laser, before this, we will drag this out a bit. We're going to get our filtered laser. We're going to, from it, get the last index. Last index. And with it, we will then say get a copy. And with this, we now have a reference to the last laser that hit our cube. And so with that, we are going to get its color. So we're going to say get color override. And now we can just simply set our color here to our current color. So drag this here, plug this in here, and there we go. So now normally if we play, we should have a blue laser or a black laser, apparently. So we haven't accessed none. So let's see why that is. So the reason for this is very simple, is because on the spawn, we don't have anything here. So this should only be done if we have an actor or at least one laser hitting. So what we'll do is we will say is not empty branch. If it is not empty right here, then we set our current color to the override. Otherwise, we just simply get the color that we already told it to use. So I'm just adding a few reroutes here just to keep things organized. Good, so we compile and save. So just to go again, if we get our filters and they are not empty, that means that we can update the color to the last one that hits. Otherwise, we want to keep using the current color that we set by default, right, for instance, here. So if we try this again, it should now all be blue. There we go. So now every laser is blue no matter what. If we block it, it stops as well, just like last time. So that does it for transferring colors over. Now, we don't actually need this because we've already tested it now, so it's not necessary. Next thing we want to do is we want to make a laser bounce. So let's remove these for now, and we'll maybe add them later if we need them. So what we need to do for our bounce is we need to make a component for it, because right now we have a handler, we have our emitter, but we don't have a bounce. So the bounce is going to be an AC handler or an actor component as well. So right click, blueprint class, actor component. AC, bounce will do. Double click to open it, and there we go. So just like with our emitter, we're going to get this right here in our event graph, copy the event begin play, and just paste it in the bounce as well, right here. Now we don't have a variable for that, so right click, create variable only. There we go, so compile. And so here we're going to need a single variable. There's only one variable we actually need in addition to this, so we're going to duplicate it, and it is going to be called emitter bounce map. And so all we need to know is here what it's going to store is it's going to store on a key which laser is hitting it, and as a value what emitter is being spawned to handle that bounce. And this is mainly useful for when we're talking about updating it. So right here we want to change this to a_laser right here, and we want to change it from a single type to a map. And for the second part, so the value, we want to look for SC_emitter. So this one right here. So we can compile twice because it will say there's an error because it's not the same type anymore. And to get things going, all we need to do now is we need to add our implemented interface again. So we're looking for BPI lasers. Once again, this is in our class settings. We've done this a few times now. We need to open start. We need to open stop. So to actually get this to work properly, we need a third function here, because right now this does our start, this does our end, but we don't have our update. So I mentioned it previously in our A laser. We also do need it in our handle here. We need to add it here. So let's go and make that function very quickly. So in our BPI lasers, we're going to duplicate our start, and we're going to call it laser update hitting. And we don't need to change anything because we need to know which laser is being updated, and we need to know how it's being updated. So we leave both of these, we compile, we save, and we can close it. So now we have our third update hitting here, which we can place right here below. So to start, let's add it. Let's do just that. So first we want to check if this is valid, because if the laser doesn't exist, especially here, we can't do anything because we need to store it as well. So we want to make an extra sure that we are working with something that exists. So first we want to check, does this contain the same laser we're trying to spawn? Because if this laser has already been spawned, meaning it's in this map, then we don't want to spawn it again because that would be useless and would just create a new actor that has no connection anymore. So we just want to put a branch here to make sure that that doesn't happen anymore, or doesn't happen. So plug this in here. Add a reroute. We're going to make a second one here, and we're going to do the same thing for our hit info, because this is going to be a function. So right click, collapse the function, spawn laser. There we go. Plug this on false, make sure it's false, not true. I'm going to put it here, and we will say laser in and hit info. So let's go and open this and create it. So for our spawning, we want to do pretty much the same thing as we did before for our emitter. The main thing we need to make sure of is that we align it how we want. So this time, instead of doing add our laser, we're going to simply add an emitter, because the emitter handles everything we need for this. So we don't want to touch it other than that. So what we'll do is we will say get owner, so that we have a reference to our actor, so that we can then say add component by class. So we plug this on right here, and we want to make sure we set our component to our SC emitter here, and we want to make sure we set up our transform correctly, because that's going to be where the main of the logic, or most of the logic, is. So get our hit info, and with our hit info we're going to break, and what we mainly need is the impact point, impact normal, and the trace start, because with this we can use the function called mirror vector by normal. And so that's what we're going to do here. So the in vector is the impact point minus the trace start. That's the in vector. And the normal is, well, it's the impact normal. That's should be pretty obvious. And so what this does is it will say, well, this is where we're going to arrive. This is where we're starting. So the directional vector between these two is this in vector, but it doesn't actually need it to be a normalized vector. So we can just leave it as this instead of doing the whole normalize that you would usually do. So we can collapse this, line this up, even though it doesn't look great. There we go. We'll just do this instead. And there we go. So let's move this slightly up. So with this, we now have a reflector, or at least the direction it will be reflected in. So to use this, we want to make sure we turn it into a rotation by saying make rot from X, because X is the forward direction of our laser itself. So that is because this is pointing towards the X. If it was upwards, we'd be using Z instead. So back in AC bounce, just move this a bit so we have a bit more space here. And before we can plug this in, we need to make sure it's turned to relative, because this is all relative position. So we want to say get owner, and we are going to say get transform from the owner. And so we have this now, and we can then say inverse transform rotation, which will convert this from world space to local, because this is all obviously in world space. So rotation, and now we have our relative rotation. All we need left is to add our transform location. So we're going to do the same thing, inverse location, plug this into relative location, and for the location we use the impact point. So it should look something like this now, with our reroutes here, just to make it more readable. So now that we have our emitter spawned, rotated, and at the right location, we are going to now tell it to save it, save the information that we need. So here we're going to say add, and the key is going to be our in value here, so our laser in, so we'll call that laser in, and the return value will go right here. So let's just add a few reroutes, and there we go. And also one thing we also need to do here is we're going to say activate laser. And because most of this will all be handled separately, where if now, for instance, this laser gets deactivated, we will call from within our laser here to deactivate. And the reason for that is because our handler, instead of doing a system where we do this every time a laser hits, we just do it once and we'll update only our bounce, and it will handle whatever it's spawned. So now we have it activated, and that will do it. So this does it for spawning the laser. Next, we'll do stopping the laser. So for stopping, we need to do another function as well. So just reroute here, select it, right click, and say collapse function. And we'll say remove laser. So plug this in here as well and open it up. Now, the first thing we need to do here is with our input pin. So we'll say get input pin. Now you could also drag from here, it doesn't matter. We want to get our emitter, our bounce map, sorry, and we will say find. Now we only want to destroy something if we know that it exists. So we'll do a branch here and say, well, if we found it, we can delete it. Otherwise, we don't want to. Now, before doing that, we need to promote this. So we're going to save this temporarily as a variable. So we'll say promote to local variable, L remove item for it. So put this on true. Yeah, so from here, we're going to call our stop hitting. So call function on the top one here. And we don't need any input here. It's not necessary. From this, we then need to do one last thing, which is called destroy component. And we're going to destroy the actual emitter itself. So our remove item. And finally, to finish things off, we will say remove from the array, or from the map, sorry, our input, which is input pin right here. There we go. So for now, we're going to leave this as is, but I think this will cause an issue because from my testing, for some reason, it doesn't seem to like doing it this way. You actually have to do it from within our SC emitter. So if that's the case, we'll just make a quick function within here to handle that. So the last thing we need to do is update. So before we do our update, just very quickly, I want to go and make our laser handle the update. So in our handle hit actors, we just want to get our handler here and say update laser hitting. So this one at the top, right here, plug it in, and we use the same information as below. So just like this. So compile, save, and we can go back to our AC bounce and start working on this right here. So to do this, what we can do is we'll start by once again doing a find. We will say, can we find our input laser and update it? If we can, so if our branch here of whether we found it is true, then we're simply going to say set world location. From here, we want to make sure we drag off from here, set world location and rotation. Just like that. And just to make this a bit easier, what we're going to do is we can actually, I think I'm going to collapse this very quickly. We're going to turn this into a macro. So right click on this, we'll say collapse to macro, and this will be get location rotation. We'll say mirror location rotation. And so this is still in world space, and we're just going to use this as world space right here. So from our hit information, we'll say, or just drag it in from here, get that information, plug the output into the new location and the return value into the new rotation. So let's just rename those. So output is location and return value is rotation. There we go. So we can compile, and now we have our system that will bounce the laser without any issues. But it doesn't work yet because we haven't set up the controller or our handler to actually do anything about that. So we need to add our update hitting here and make it do the same thing pretty much. So the update, pretty simple. We're just going to copy this and say update. It's really that simple. We don't have any other things we need to do. So we're just going to remove our stop and say update hitting message. Once again, it's a message because we don't know which actors we're talking about. So we just plug these two in right here. I'm just going to add a reroute to make it a bit more tidy. There we go. And another one right here. And this should do the trick. So right now, we can't test it because we don't have a wall yet. So let's make that. So in blueprints, right click, blueprint, actor, and we're going to say a_reflect. And for this one, I think we will use, I believe the mesh is called ramp. So let's get that. So static mesh again. Let's get the basic one. And we will look for ramp. Place it here. And we will make sure this is attached instead of the scene root. And now we just need to add our components. So AC bounce is the main one we need. But it won't work without our AC handler. So we make sure to call that one as well. Now that's all we need. Just check that our conditions are correct. So we don't want to invert the system. It doesn't work anyway. We can make it blocking. It doesn't have to be, but it can be blocking. Or in most cases it is. Bounce, we don't have anything to do. We can actually make this private because it's not necessary. So I'm just going to turn both of these to private because they don't need to be used elsewhere. That's the wrong thing. Private and private. There we go. So if we look now at our reflect, they're not visible anymore. And this should do it. So if we hit anything on here, it will work to make it bounce. So let's go and add our reflect. So we have a laser here. So let's just make it bounce that way. So I'm going to make it a bit bigger so that we can bounce it correctly. And let's move it about here will do. And we'll move the player a bit. There we go. So now normally we have a bounce, and if we block it, it disappears. There we go. So right here, it is constantly updating. So as it should, because right now if this moves, it shouldn't be a problem. So to test if that works, let's add a cube. And the cube, for some reason it made two there. Let's see how it works. So laser will go right through it, and there we go. So let's see what happens if we move it along the wall here, because it is moving, it is updating as it moves. So that's exactly what we want. So it's working just fine. Now, to make sure that this is working correctly, let's add the cube to about where it should bounce. So it should be about here. It's not perfect, but it should hit it. And I got it a bit wrong. So let's move this. And we have a laser that spawns, a laser that bounces, and a laser that is redirected. Let's see if we block this. The redirection stops as well. The laser stops behind us, and if we make it bounce, it starts again. If we block after the bounce, same thing. The laser stops here, and it goes again. So that is working exactly as intended. The color is going through as well. And I believe that will do it for this part. I hope you enjoyed. Thank you for watching. Once again, thank you to everybody on Patreon who supported me. The project files for this will be available once the last part comes out. And I think we have maybe 1 or 2 parts left. I think 2, maybe even 3. I'm not 100% sure, but we'll see. Thank you for watching again, and I will see you in the next part. Goodbye.